Today's lesson is over quadratics in context and the square root method. So we're going to start with some basic square root knowledge. Mentally, we can figure out what x could equal in each scenario. Remember that x could either be a positive or a negative answer. So x here is either positive or negative 4. Notice that I'm using the positive and the negative symbol before the 4. Little left writing. So here we get positive or negative 9. Either of those squared gives us 81. And here, either positive or negative 5. And here, well, there's really no positive or negative 0. It's just going to be 0. So, possible solutions to any quadratic equation? Well, there could be up to 2. So, a little bit of review of inverse operations. I'm going to abbreviate some things here. We know that in traditional equations, what we've seen so far is that addition and subtraction undo each other, the same way that multiplication and division undo each other. Now, to undo an exponent of 2, we're going to square root each side. And yes, I just made square root into a verb. We square root each side. So let's take all of our knowledge of inverse operations and apply it to the following problem. We've got 4x squared minus 10 equals 54. So I'm going to start by adding 10 to each side. And this goes away. Left with 4x squared equals 64. Now we're going to divide both sides by 4, clear out the coefficient. Left with x squared equals 16. And now we square root each side. There's that new verb again. And we're going to get x either equals positive or negative 4. So let's go ahead and work on the next 4 problems. I advise you to stay with me for these. They're all a little bit different. So 2x squared equals 8. Actually, you guys can do this one on your own if you want. We divide both sides by 2. Left with x squared equals 4. And then x equals positive or negative 2 after we square root both sides. That was nice and easy. Now we've got b plus 1. That quantity squared equals 16. Well, let's go ahead and let's just square root each side right from the get-go. So b plus 1 is what's left on the right side, the left side, excuse me. Then over here we've got positive or negative 4. So I'm going to go ahead and write it as 2 separate equations. So we got b plus 1 equals positive 4, and b plus 1 equals negative 4. And we should be able to see pretty quickly that here b equals 3, and then here b equals negative 5. So all these worked out to be nice and easy whole numbers, or integers, no decimals or fractions. However, that won't always be the case. So here, x squared minus 5 equals 17. We're going to start by adding 5 to each side. Left with x squared equals 22. So I'm going to go ahead and square root each side. And then we're told in the above directions to round to 3 decimal places. So with my calculator, I do radical 22, which leaves me with 4 and 69/100ths. The number after the 9 is a 0. No need to write that. So that wasn't too bad. Now over here, it gets a little more complicated. So we start by dividing 4 on each sides in problem number 4. So we got b plus 1, that quantity squared, equals 7. Now we square root both sides. We've got b plus 1. It equals radical 7. We're going to go ahead and simplify that into our 3 decimal places. So we're going to get 2 and 648 thousandths. And that can be positive or negative. So we're going to go with our 2 equations again. So we have b plus 1 equals positive 2 and 648 thousandths. I'm going to go ahead and finish that one off real fast. So we could have over here b equals 1 and 648 thousandths. Other possibility is b plus 1 equals negative 2, 648 thousandths. Subtract 1 from both sides. And here we get b equals negative 3 and 648 thousandths. Okay, so those are our 2 possible answers. And finally, a proportion. Now we should know that our cross products in any proportion are equal. So we multiply diagonally. So we've got 2 times 10 equals 20. Then we just multiply the x's to get x squared. Okay, we square root both sides, and we've got radical 20, which, after using the calculator, is 4 and 472 thousandths. That can be positive or negative. That is equal to x. So go ahead and try these problems on your own. I'm going to show you the 4 on this page so you see them. And if you want to pause the video, go ahead. Otherwise, stay with me. Start this first one by adding 15 to both sides. Got 4x squared equals 144. Divide both sides by 4 to get x squared equals 36. We square root both sides, and x either equals positive or negative 6. Moving over to problem 7, we can divide both sides by 3. And we've got x squared plus 2 equals, that would be, what is that going to be, 66. Subtract both sides by 2. Left with x squared equals 64. And then we square root both sides. We have x equal to positive or negative 8. Okay, move this out of the way. Okay, problem 8. We are going to proportion it. Cross multiply, we get 90 is equal to p squared, right? Because 15 times 6 is 90. And p is p squared. We square root both sides. And our square root of 90 is going to be 9 and 469 thousandths. So that's going to be positive or negative. That's equal to p. And finally, number 9, we divide both sides by 3, as we saw above. This leaves us with 66 on the right side. We square root both sides. So x plus 2 is going to equal positive or negative 8 and 124 thousandths. Okay, 2 equations for now is probably our easiest way to go. So this one will be x equals 6 and 124 thousandths. And then our other one, so I should probably write x plus 2 there. So x plus 2 equals negative 8 and 124 thousandths. Subtract 2 from both sides. X equals negative 10 and 124 thousandths. About the word problem. We're trying to create a bigger and better aluminum can for soda. We know that we want it to hold 60 ounces and to be 5 inches tall. What would be the radius of the can would have to be? And we got our volume formula, which is there, V equals pi r squared. So let's go ahead and plug in what we know. We know that the volume, we want it to be 60 ounces. We're going to use 3 and 1400ths for pi. And we know we want the height to be 5. We don't know the radius yet. So multiply 3 and 1400ths by 5 to give us 15 and 7/10, radius squared. We divide both sides by that 15 and 7/10 to give us, sorry, I'm trying to catch up to my voice here. We have 3 and 821 thousandths to equal r squared. Okay, we go ahead and we square root both sides. So I'm going to go ahead and do that on the calculator. Now I'm going to get 1 in 955 thousandths. And since we're dealing with volume and all positive numbers, no need for the plus minus, okay? Keep it in context. Okay, there's your final answer. Now for our final problem. Okay, maximum speed, denoted as s, is going to be, the equation is s squared equals 16/9 x, where x is the length of the water line in feet. Find the maximum speed of the boat with a 25-foot water line. Let's go ahead and write that equation up and plug in what we know. We know that our x in this case is going to be 25. We're dealing with fractions, so always like to write it as 25 over 1. And s squared would equal 400 over 9. Now what's nice here is that 400 and 9 are both perfect squares. So we square root both sides, we just got to square root each part of the fraction. Okay, so the square root of 400 is 20. The square root of 9 is 3. So we've got s equals 20/3. And again, we're dealing with positives, real life situation, no need for the negative parts. You can write it as a mixed number as well. This includes your lesson over contexts and square root method.